Kids all have a Canvas calendar that is supposedly synced with mine, so you can always check that for your units. All right. Notes out. Here we go. We are going to do P7, which is all about inequalities. Okay? There'll be several kinds of inequalities. Now, I know that you all solved this last year, this kind of problem last year, with either Mrs. Hollis or Mrs. Ludington. And I am quite confident that you can still solve it that way, but I want to show you a new way. A way that's a little less confusing, I think. It's different, but it's pretty easy. Here's what I want you to figure out. This, I'm drawing a number. And in the middle of the number line, I'm going to put the opposite of that number. So I'm going to put a 3 right there. Because this problem literally says the distance between some number and 3 is less than 4. So there's 3. Now where is x? Well, x could be out here or x could be back here. I'm not sure, it could be on either side. But I know that this distance is 4. So where is this x? If that distance is 4, this x has to be at 7. Where is this x? This is also 4, negative 1. Now, those 2 points are exactly 4 units away from 3. Would you agree with that? I want points that are less than 4 units away. So if these are the ones that are exactly 4, won't these be the ones that are less than 4? So I'm going to shade in between my 2 dots, and right there is the answer to the problem. I don't even really need to do any math. I don't need to set up 2 equations. I don't need to flip any signs. I don't need to make anything negative. I just look at my number. So let's try this one. Now be careful. What's going to go in the middle of my number line this time?
6.
Be careful.
Negative 6.
Negative 6. Negative 6. This is a difference. You can just remember it as you put the opposite of the number. So that's a minus 3, I put a plus 3. That's a plus 6, I put a minus 6. Then there's going to be a dot out here and a dot out here. They are closed this time. And to figure out where those dots go, I'm going to count that many. So I'm going to count ahead 5 and back 5. So where will I be if I count ahead 5? Negative 1. And how about back 5? Negative 11. Now those 2 points are where I am exactly 5. This time I want to be more than 5, further away than 5. So I'm going to shade out here and out here. So what is my answer? Well, remember, this is negative infinity, and this is positive infinity. So we'll go from negative infinity to negative 11. And then we'll union that with negative 1 to infinity. Done. No math. Now, what's a little bit different about this next one? There's something different about it. What do you notice? Got a 2 in front. We cannot have a 2 in front. We can't have anything in front. So what do you think I might do if I'm not allowed to have that 2 in front? Divide it out. and I divide everything by 2. So now my problem says the absolute value of x minus 1/2 is less than or equal to 3/2. So I'm going to draw my number line, and what's going to be right in the middle? 1/2. I'm going to have a number over here and a number over here, and those will be solid dots again. Are you keeping up? Now I need to figure out where they are, so I'm going to start at my 1/2 and count 3/2 both directions. So 1/2 plus 3/2 is 2. And 1/2 minus 3/2 is -1. And then I gotta figure out where I shade. So right here, it's a less than. Where does less than shade? Inside. So my answer, very simply, bracket -1, comma. Well, if you have 2 shades, you have to use it.
Okay.
If you only have 1 shaded area.
Oh, if you're going opposite, yeah.
Okay, all right, there's one more. Try this one with your partner. It's like the one we just finished. Think about what we've done. And see if you can come up with an answer to this. Let's have a, somebody got an answer yet? Anybody have an answer? Okay, you? Not that you want to share? Oh, come on, I want to be great. What'd you get? Numbers aren't right. Lola, you guys got an answer you're willing to share? Not Lola. Grace, you got an answer you're willing to share?
Negative infinity and 5/3, and then U 7/3 to infinity. With
Negative infinity 5/3, and then
7/3 to positive infinity.
now I don't know if that's right. That's their stab. Anybody get it? Same thing? You got a different stab?
I got different, yeah.
What's yours?
Negative infinity to negative 7/3, and then union negative 5/3 to positive infinity.
All right, so we are very close. We have a sign issue somewhere, right? So let's figure out what's going on. First thing you did, I hope, was divide everything by 3,
Yeah.
so that your problem says x plus 2 greater than 1/3. So Grace, remember when you do this, right in the middle goes the opposite of that number. So that's going to be a -2, and then we're going to go forward and backward 1/3. This is -6/3. So if I add 1/3 to that, it'll be -5/3. And if I subtract 1/3, it'll be -7/3. Now it's a greater than. Greater than means I want to be farther away. So I'm going to shade out here and out here. So I think this is the right answer right here. What do you think? Does that look right?
Yeah.
The girls were exactly on the right path, but they were not careful about this number. We have to start with the opposite. You okay with that?
Yeah.
All right, move right here. All right, so P7 is all about inequalities. So we've talked about absolute value. Now we're going to move on and talk about polynomial inequalities. Pardon me? Oh, you're doing 2A? Okay, yeah. So Elijah says he has no idea, or I don't know if he does or not, but he has an idea how to start. He says, let's just factor it. And his suggestion was that we use 4 and 3. That seem reasonable, everyone?
Yeah.
All right, so now we're gonna do exactly what we just did. We're gonna draw ourselves a number line. We're gonna put 2 dots on that number line, and they will be open dots. Where do you think those dots will be? -4 and -3. And guys, this is a number line. So think about zeros out here somewhere. So -3, -4. That's the order they have to be. Is that all right with everybody? Now, a minute ago, when we had 2 dots on the number line, and that was a greater than, we took our 2 dots and we shaded out from them. Now I have my 2 dots, but I have a less than, so guess what? I'm gonna shade in between, just like I did before. Less than means inside. Less than means inside your dots. If you have 2 dots on your number line, I don't care what kind of problem it is. If you have 2 dots on your number line, less than is going to be inside, greater than is going to be outside. So the answer to my question is -4, -3. Open dots, parentheses. Now, I don't know about you, but this doesn't seem too bad. Let's try the next one. What do you think about x squared minus 16?
Factor in x plus squared.
It's the difference of squares, right, so it factors how?
X minus 4.
X minus 4, x plus 4. Everybody good with that? So what am I gonna do now? Draw my number line. I'm gonna have 2 dots on it, and this time they will be
Positive 4, -4.
closed. And there'll be a +4 and -4 in that order. That's a number line. Don't be screwing with the numbers. It's a greater than problem. So where is greater than shaded? Out. Elijah, 2-part graph, 2-part answer. So this part will be,
-10.
and the 4 will be bracketed.
And then bracket 4. Positive.
Yes. Okay. Uh-oh, uh-oh. What is different about C? Just when we thought we had this under control.
Cube.
It's a cube. Now, there's a couple of things that are gonna change, but a lot of it's gonna stay the same. First thing you wanna do is factor it. Okay, so what? Take out an X. GCF. Anytime we have a GCF, we wanna pull it out. So, take out the X, and we're left with x squared minus 4. And then x squared minus 4 is
X minus 6.
minus 2 plus 2. Now, do not lose the x. The x has to stay. It's part of the problem. We can't lose it. Come on.
Yes, 0.
That'd be 0.
Exactly. Very good. Whoever's out there saying 0, exactly. So this is gonna be a dot at 0. A plane x, you hearing me? A plane x is a dot at 0. This one would be at 2, and this one would be at negative 2. So get them on here in order. They've got to go on the number line in order. They would be open dots. And now this is where things change, because when we had 2 dots, we knew we were either going to be out or in, right? Now I have too many dots. So here's what I want you to do. I want you to pick a number, and technically it can be any number that's not a dot. So you can pick a number here, 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 okay? I suggest you just pick a nice number, a nice positive number right here, like 3. You don't have to pick 3. You can pick whatever you want. I'm gonna pick 3. Take that 3 and plug it in here and here and here. Okay? So I would have then, if I did that, I would have 3, actually, I'll do it over here. I would have 3 times 1 times 5. Would you agree with that? I'm putting a 3 in for all my x's. So 3 minus 2, 3 plus 2. What happens when I multiply all those together? What do I get? 15. Is 15 bigger than 0?
Yeah.
Okay, that means this gets shaded. Because 15 is bigger than 0. If I had gotten negative 8, then I wouldn't shade it. Because my answer has to be bigger than 0. Okay? Now, I could I pick a number in here and do exactly the same thing to see if I shade that section. Yep, and I could pick one here and I could pick one here. I could pick 4 numbers, 1 per section, and figure out if I shade. But there's a shortcut, okay? It doesn't work all the time. I'll tell you when it doesn't work. But the shortcut is this, and we have learned this last year. The shading in a normal problem, and I'm going to tell you what's abnormal, but in a normal problem like this, the shading will always alternate. So since I already figured out this one shades, I know this one won't, this one will, and this one won't. That happened in our other problems. We didn't really talk about it, but look, shade, not shade. The ones that were shaded in the middle were not shade, not. It always alternates. Okay, I gotta qualify that always. When the shortcut won't work is when you have a problem that has a power on one of the factors. If you have a problem that looks like this, has a power on there, then you are gonna have to pick a number in each section because it won't alternate. You'll have consecutive sections doing the same thing. So as long as there's no power, figure out what's happening out here and then just alternate the rest of the way. Okay, so what's my answer? Negative 2 to 0 or 2 to infinity. Alright. Man, I hate when we come back from lunch, you're all like zoned out. So let's put a little excitement in here. Let's try D. With your partner, And maybe there's somebody or some pair of you that would actually come up and do this on the board for us. It's just like one we just finished.
Oh, wait.
That's
Pretty
good.
close.
Formula you
Fuck,
would do.
you say,
Oh, wait, never mind.
Just don't leave it on when you're not focusing in class. I'm serious.
you got that going.
You got it done already?
Yeah, it's something on the outside.
Well, how do you know it's not right?
I did X.
Just pick like one. Pick like one.
Alright, so Keller has already finished the problem. So I hope, Keller, you factored. How did you factor that?
X and then X minus 6, X minus 5.
Whoops,
X plus 5. That's 5.
that would have to be the plus,
Yeah,
right?
yeah, that's what I meant.
Yeah, okay. What do you think about Keller's factoring? Good?
Oh, I said X. I put that side.
So we remember that anytime we factor, we can do a quick check by foiling it back. So you might wanna just do that if you're prone to make careless mistakes. Go ahead and foil it back and make sure it matches. This does. Okay? So no one volunteered. What should we have done at this point now? We have a factor. There's going to be 3 dots on the number line, and they're always colored in. Remember, however many X's there are is how many dots you have. Okay? And where will they be? 0, 6, and -5. So -5, 0, 6 in that order on the number one. Too many dots to do the outside inside thing, so I'm going to have to pick a number. I'll just pick 7. And every time I see an X, I'm gonna put a 7. So 7, this parentheses would be 1, and this parentheses would be 12. Now, you don't need to know, I mean, it's fine, but you don't need to know what 7 times 12 is. All you need to know is it's positive, right? Is a positive number gonna be less than 0? No. So when I put in 7, it didn't work. I need numbers to be less than 0. I need answers that are less than 0. And 7 times 1 times 12 is bigger than 0. So this didn't work, which means I won't shade it. And if I don't shade that one, then I will shade this one, and I won't, and I will.
Wait, how did that work? Like you welded the,
What?
oh, it's all oh, okay.
So your answer, I can't remember what you had, Keller. Nothing close to that. This is the answer. Now, did any of you people who wouldn't volunteer, did any of you get that? Uh-oh. Did you follow what happened?
Yeah, we got like.
Anyone have a question about that? We're gonna do one more problem. You're gonna hang with me for one more problem. And it looks like an easy problem. Compared to this. All right, so factor it, have to factor. x minus 4. Okay, now wait a second. I don't care whether you write it this way or not, but would you agree that's the same as this? Okay, this is when we have problems. Okay? So here's my number line,
Wait,
and there's,
you have to write it?
you
like, with
don't
the
have to,
extra-
but you need to recognize you have a problem here.
Uh-huh.
Because your two parentheses are gonna give you just
The same thing.
one number. So you are gonna have a dot, a closed-in dot at 4. Would you agree with that? I have no idea where to shade. I can't do outside inside because I only have one dot. I got this squared, which means nothing alternating works, so I have no choice. I'm gonna pick a number over here, like maybe 5, and see if it works. If I put in 5, either put it here or here, it doesn't matter. If I put it here, 5 minus 4 is 1, and 1 squared is 1. Is 1 less than 0? So I won't shade over there. So now I'll come over here and maybe I'll try 3. 3 minus 4 is -1. -1 squared is 1. Is that less than 0? Guess what? We don't shade at all. The only answer to the problem is x equals 4. That got colored in. That's the only answer to the problem. Now, what if this hadn't been there? Then that dot would be open, no solution, because absolutely nothing's colored now. Right? Nothing's colored. So that would be no solution. All right, go ahead and gather up. I got a few papers to hand back.
It's this Sunday. Next Sunday, I mean. How much are the tickets?